this video, we're going to look at how to summarize a categorical variable using R. Before we get started, there's 3 pieces of information you're going to want to make sure that you get from Canvas. The first one is going to be the Module 6 R script. You'll also want to make sure that you have access to the codebook for the BRFSS dataset. And then finally, the BRFSS dataset that was provided to you on Canvas. Now, a little bit of warning about that dataset. It is a very big file, so do not try to open it in Excel or any other program. We're going to open it in R. And again, it's a pretty big dataset, so if you try to open it and view it in Excel or another program, it's really going to slow down your computer if it will even open at all. All right. So the very first thing we're going to do is we're going to read the full data set into R. Now, each of you in your groups have been assigned a specific state. How these videos are going to work is I'm going to show you how to do everything for the state of Kentucky for just a handful of variables. And then the main thing that you'll have to do for your reports is you'll want to change everything to reflect your state, as well as whatever variables it is you want to explore. And I'll talk about where to make the changes in the code. So to get started, let's go ahead and get that data set and read it into R. So the very first thing that I'm going to do is set my working directory. And so remember, setting your working directory, that's telling R where the files are located. So R is going to know where to find the data set. And there's a couple different ways that we can do this. The easiest way is to come over to the bottom right-hand window, click on Files, click on these 3 white dots, and then you're going to want to navigate to the folder where you have saved the data set. Now here in this viewer, this is only going to show you folders that are on your computer, not individual files. So keep that in mind. You're not going to see all the files here. You're just going to see the folders. So for example, on mine, I have mine saved in my Google Drive. So I would go through here, find the classes. Here we are, CPH 603, Spring 2021. And again, notice you're not seeing any files, you're just seeing folders. And then I get down to the folder where it's located and click OK. That will open up the folder here, and now all the files in that folder will appear. Now I have a lot more files in mine than you probably have in yours, but the main file that you want to make sure that you have is that BFRSS dataset. Alright, so once you have the correct location opened here, if you click on More, you'll notice one of the options is Set as Working Directory. So clicking here will auto-populate that code that you need. So if you want to, so that you have it for later use, you can copy this and then just paste it right here so you have it. So now this code has been ran because it appeared in our console, so we've set our working directory. So the next thing we're going to do is read in the data set. We're going to use the read.csv function. You've seen this before. And so notice I'm going to create an object called BRFSS data. I'm going to set it equal to, and then here in the read.csv function, I've provided the name of the file in quotations, and then we're going to set header equal to true. And the reason for that is this data set does have the names of the variables across the top, so header equals true lets R know, hey, we need to read in those variable names. All right, so reading this in. It's going to take it probably a minute. Again, very, very large data set. So what you're looking for is down here in the left. Notice how there's nothing after the line of code that I ran. So you'll just want to wait until another little kind of arrow appears here on the left-hand side, and that will let you know that it has ran. And again, it might take it a minute because this is a really large data set. All right, so mine has now ran, and notice my data set has appeared up here at the top. The full data set has a little over 400,000 observations with 275 variables. Again, a very big data set. So the first thing that we're going to do is we're going to make a smaller version of this data set. Now in the video, I'm going to make a version that only includes data for Kentucky in 2018 because we're looking at the 2018 data. You are going to make a smaller data set that just has the data for your state. And I'm going to show you how to do this. Once we complete these steps, this will be the only time in this course you need to do this. Once we have the smaller data set that just has your state's data, you're going to save that file, and that'll be the file you read in for the rest of the semester. So if you find yourself repeating these beginning steps each time, you'll know that you've kind of missed something. You don't want to repeat these steps. This should be the only time that you're doing this. All right, going back to our script, notice I have put in that view statement to view the data set. I don't actually recommend doing this. If you want to, you can run it, but it's going to run pretty slow. Probably go grab a coffee, come back, and you can view the full data set. But again, the data set's really large, so I wouldn't recommend this. All right, so now we're going to create that smaller data set I was talking about. In order to create this smaller data set, I need to know how the state is coded in the data set. So to do this, I'm going to need to go to my code book. All right, so here is the code book, and remember that the code book has all of the variables as well as how they're coded and the values they take. And one of the very first variables located in the code book is actually the first variable is the state. So one thing that you're going to want to look for is its SAS variable name. Now we're using R, and that's perfectly fine, and the variable names are going to be almost exactly the same. The only difference is when R read in this data set for this variable, it read in underscore state. Well, R will not let variable names start with an underscore, so R is going to automatically put an X in front of that. So in R, this variable is going to be X underscore state. And again, that's just because R doesn't let variable names start with an underscore. Now, if I scroll down here, notice that Kentucky is coded as 21. You'll want to find your state and see what value your state is coded as. Alright, so the very first thing I'm going to do is I'm going to create a smaller data set that only contains the data for Kentucky. So to do this, I'm going to create an object. I'm going to call it KY underscore data. This is the same as the equal sign in R. And then what I'm going to do is I'm going to call that BRFSS data that I just created. And what this is doing, the square brackets afterwards, anything before the comma is going to call on the rows. Anything after is going to call on columns. So looking before the comma, I've got what is called a logical argument. And so what this is doing is it's saying, all right, I want you to look at the X state variable from the data set, and I want you to find all the rows where that variable is equal to 21. And notice I do have that double equal sign. You do need the double equal sign. So what this is going to do is it's going to pull all of the rows from the data set where this variable is equal to 21. In other words, it's going to give me all of the Kentucky data. For your data set, the only thing you're going to need to change here is the number. And you'll want the number that corresponds with your state. And then, of course, instead of naming it KY data, you'll want to name it something that's fitting for your state. So let's run this. Notice that ran much quicker. And if I come over here, notice in my global environment, I now have a new data set called KY data. This data set still has 275 variables, but now notice it just has a little over 8,000 observations. So we've already drastically reduced this data set. And if we wanted to, we could view this data. Now remember, I don't only just want data for Kentucky, I want data only from the year 2018. So there is another variable in the code book that is called year. And so that is going to be the year in which the data was collected. So I want to show you a trick with the code book. So I'm going to bring the code book back over. This code book is huge. It has 154 pages. And so scrolling through the code book, can be pretty difficult if we're looking for a specific variable. So kind of a trick to do this is if you click here, if you're on a Windows machine, click on Control F, and that's going to bring up Find. And so we can use Find to look for different words in this document. So the variable name that I'm looking for is year, so I'm going to click on that. And then if I click Next, it will take me to the place in the document where that is. And you'll see here we have that SAS variable name I-year. It's the same in R because it got read in the same way. And notice it takes the values 2018 and 2019. Now we only want the values from 2018, so I'm going to move this over. Now if I wanted to explore that variable and see what it looks like, we could use the table function. So notice here I have table. Next I have the name of the data set, $, and the name of the variable I'm interested in. So what this tells me is in that Kentucky data set that I've made, I have 6,604 observations from the year 2018 and 1,944 observations from the year 2019. So what I want to do next is I only want that data from 2018. So I'm going to do something very similar to what I did before. I'm going to name this new data set Kentucky 2018 data. I'm going to set it equal to the Kentucky data, and I'm going to pull the rows from the Kentucky data where I-year is equal to 2018. So when you do this, the only thing that you're going to need to change is instead of calling the Kentucky data set, you're going to want to call whatever you name that data set up here. So let's run this. And so now we have a third data set. Notice it's even smaller. It has 6,604 observations of 275 variables. And now if we want to, we could use that view function and we could view this new data set. Now this new data set, this is going to be the data set that I'm going to work on in these videos for the rest of the semester. Your data set that you create is going to be the one that you work with for the rest of the semester. Now while this is pulling up, because it's still pretty big so it takes it a minute, but while this data set's coming up, oh it's up now, but one thing that I do want to note is some of you for your projects may want to reduce your data even further. So for example, if you're working on women's health, you might want to do a similar thing to reduce your data to only include women. Or in the past I had a student who did one of these reports on Native Americans. So he took his data set and he made it so it only included Native Americans. If you're doing something similar to that, you can use very similar steps to do that, or if you need help doing that, just let me know. Alright, so here we have our full data set, and again 275 variables, so we can see, still pretty big. But one thing that I do want to bring your attention to is as we scroll through here, we're going to see a couple columns, if I can find one here, that is all NAs, and an NA and R stands for missing. So for example, here are a couple right here. These are all NAs, and we scroll through here, and take it a minute to load, you're going to see that those are still NAs. So everyone's data set that they read in is going to have 275 variables, but for some of those variables, all of the values are going to be missing. The reason for that is remember that the core questions all of the state ask, but there are those optional modules that only some of the states ask. So these variables correspond with an optional module that Kentucky didn't ask during the survey. So it's still included in the data set, but it's just going to be all missing for the state of Kentucky. So keep that in mind while you're looking at your data set, and make sure you're not trying to analyze a variable that's from a module that your state did not include. Alright, now the last thing we need to do is we've created this data set. This data set currently lives in R, but we want to make sure that we can use this data set again in the future. So this write.table function, this is going to take that data set we just created, it's going to write it as a CSV, and it's going to put it on your computer. So I've made some notes here about what the different lines do. The main things that you need to be concerned with are this one right here. So this is the name of the data set that you created in the steps above, and this line right here. This line right here tells R, when you save this file to my computer, this is what I want you to name the file. So the file it creates in my case is going to be equal to Kentucky_2018_data.csv. So you do want to have that .csv after yours. So if we run this, it'll take it just a minute, And then if you come over here to the right, remember that these are all the different files on your computer. If you scroll down, since we have set our working directory, you should now see that new file, that CSV. And this is CSV you could open in Excel, you could open it wherever you wanted to. That file now lives on your computer. So this should be the only time in this course that you do these steps. From here on out, when working with the data for your report, you're going to work with the CSV that you created, not the full data set. And again, you want to do this because the smaller data set is much more manageable and easy to work with. Alright, so we're going to move on to how to build frequency tables, bar charts, and pie charts in R. And one thing that you're going to notice is my code has lots and lots of comments so that you know what each of the different lines are doing. The other thing, or not the other thing, but I want you to really pay attention to all of those comments, because as you write your code, you're going to turn in code for assignments. I'm going to expect to see that level of commenting in your code as well. By putting these comments in, that's going to help you better understand what the code is doing. It's also going to make it easier for you to go back and read your code later on. So let's start out by making a frequency table. I'm going to do this for the education variable, but you could do something very similar for any of the other categorical variables in your data set. So before we get started, let's look at that education variable. And the education variable is educa. So again, I'm going to go back to my code book. I'm going to search for that variable name. All right. So this variable looks at what is the highest grade or year of school that has been completed. Notice here are the different values that the variable can take along with their frequency. Now, this frequency is for the full data set, so the frequency we find here and you find for your state is not going to be the same. And then the other really important thing to notice here is the value. The value is how this data set is actually coded in the data set. So anywhere we see a 1, that means they never attended school or they only attended kindergarten. We see a 2, grades 1 through 8, and so on. So let's use R to explore this variable. Well, in R, if we ever want to just call a single variable from the data set, how we can do that is we start out by typing the name of the data set. So in this case, the data set I'm working with is the KY_2018_data. And notice that as I start to type it, R is smart enough that it will auto-populate and give me some options. So if I don't want to type it all out, I can click on that. And then to call a variable from a data set, what we do is we type the $, and notice R is going to show me all of the variables that are in this data set. Now remember, there's 275 of them, so I could either scroll through this list and find the one I want, or I can start to type the name, and R will narrow those options down based on the other variables in the data set. So I want the educa. So if I were to run this, what this is going to do down here in the console is this is going to print out all of the values that we had for this variable in our data set. Now remember, again, there's 6,604 observations, and so you'll notice here R says, whoa, there's way too many, I can't print all of these out. So in general, we're not going to print those out. I just wanted you to see what that piece of the code is doing. So that piece of the code is pulling that variable from the data set. So the very first thing we're going to do is we're going to check to see if there's any missing values for this data set, or probably for this variable. Anytime you work with a variable, you're always going to want to check to see if there were any missing values, and you're going to want to document that. And you'll see that in any tables, plots, any type of summaries you're doing, you always just want to make a note, were there any missing values for this variable? So we're going to use this line of code right here. So to use this line of code to see if there's missing values, the only thing you're going to have to change is the name of the data set to be your data set and the name of the variable you're interested in. What this code is doing is it's going to go through, and for this variable, it's going to say true and false whether or not there was a missing value, and then it's going to sum all those up. And so what this does is it gives you the total number of missing values. So if I run this line of code, we see 0. So this particular variable for the Kentucky data set had no missing values. It's possible in your data set there are missing values for this variable. So we're going to start out by just making a simple table of education levels. And to do this, we can use the table function. So notice what I'm doing here. I've got the table function, and inside of the parentheses, I'm putting the data set $ name of variable. So you're going to see me use this structure a lot. And essentially what this is doing is this is asking R to make a table of this variable. So we run this, and now we've got that frequency table. But this is a little bit difficult to read. So what this says is there were 4 observations that had value 1, 209 that had value 2. But we've got to go back now to our code book and see what the values 1, 2, 3, 4, and so on represent. So looking here again at my code book, what this tells me is I had 4 respondents who had never attended school or only kindergarten. Oops, let me bring that back up. 209 that attended grades 1 through 8, and so on. So we might want to make a table that had those actual labels so we're not having to go back and forth. And that's what all of this code is doing. So the first thing that I do is I create a vector where I'm going to store the names of those levels. And I want to make sure that they're in order. So I've got C. C is the combine function. So anything inside the parentheses that follow, it's going to combine them together. And so what I've done, again, go back to our code book, notice inside the quotations and then separated by commas, I've got each of these. So I've got kindergarten or less, elementary, some high school grad, and then so on. And so you'll see each of those there. And so you do want to have those in parentheses. So here, if we run this, and then I could highlight just the ED level portion, or here, let's do this. We'll write it down below. I'll add this into when I post this. So I could just run this object and see what it looks like, and notice it now has all of those levels. Next, what I can do, instead of just calling the table like I did here, I can assign it to be an object named education.freq for frequencies. Right? So notice education.freq now appears up here, and it is a table. It's just R has stored it, so I can call it later on. I could look at the object just like I did with the ED levels, and you'll notice that's the same table we saw before. And then I could use the names function to then assign the names to it. And then now recall the table, and notice now the numbers have now changed to labels. So for you to do this, you would just want to do something very similar. It will be the same structure, but whatever variable it is that you want to change, you'll just want to give it some meaningful names. So let's say, for example, you were going to summarize race. Instead of ed levels, you could call this race levels. Here, you would type in the different levels of race based on the code book. Instead of education.freq, you might want race.freq. And then same thing here for the table. You wouldn't want to call the education variable, you would call the race variable. And then if you name that object race.freq, you would do the same thing here. So again, mainly what you're going to be changing is you'll want to make the objects reasonable names to match the categorical variable you're looking at, and then make sure you call the categorical variable that you're interested in, not education like we did here. Now, one thing that I do want to say is the tables that are created in R, they're not very nice. The only thing you're going to be using R for is to get the values for the table, not actually make the tables. You'll want to make the tables in Word or whatever other program you're using to actually type your report. You're really just using R to get the values, not actually construct the table or the format of the table as it's going to go into your report. Now, typically, in public health, you're going, especially in this case, we're working with this sample from the BRFSS. you're not actually going to be interested in counts. You're going to be more interested in relative frequencies for your reports. So any of the summaries that you give, we really want to use relative frequencies. So let's see how to make a relative frequency table. The very first thing we need to do to make a relative frequency table is we need to figure out for the variable how many responses did we have. So in other words, how many were not missing. Now for the Kentucky data set that I'm looking at here, remember I didn't have any that were missing, so I know for this variable I've got 6,604 observations, but let's see how we could actually calculate that number. To do this, I'm going to create a new object called nResponses, and I'm going to set it equal to, first thing I'm going to do is find the number of rows that are in my data set. So this will basically tell me the number of observations. And then I'm going to subtract off the number of missing values for the variable I'm interested in. So notice this is the exact same piece of code that I used all the way up here at the top to see how many missing values there are. So to find the number of responses for a different categorical variable, the only thing that you'll need to change here is the name of the data set here, and then the variable that you're interested in. And you will need to redo this for each categorical variable you work with. So it might be a good idea, instead of naming it nResponses, I'm going to name it nResponses.ed because this was for education. And then to make the table a relative frequency table, the only thing that we have to do is divide the table that we made previously by the number of responses that we found for that variable. So notice here I've got the table code that we saw earlier divided by the number of responses, and I'm going to set this equal to education.rel_freq because this is going to be a relative frequency table for the education variable. So again, when you do this, mainly what you're going to be changing is make the objects reasonable names, and then you'll change the data set and the variable that you're looking for. So again, if you want to do this with race instead of education, you could call it race.relativeFrequency. Here you would want to call the race variable and make sure that you calculate the number of responses for the race variable. So if we run this, I've called the table here at the end, and then down here again we've got the relative frequencies. Now, and I could go through and change the name of the relative frequency table to match the names just like we did with the regular frequency table. Now one thing that you'll notice here, a lot of digits. Maybe you want to go ahead and use this to find just the significant digits. So we can use this code right here. And this is going to find our significant digits up to 2 for this particular variable. And so we apply this to the table we just created. And here we go. Now, one thing to keep in mind again is you're going to be taking the values from R and putting them into Word. So if you just want to do the rounding yourself when you moved it from R to Word, that would be perfectly fine. And then the last thing we might want to do is maybe when we want to combine frequency, relative frequency. Oh, sorry. I skipped one thing here. We might want to create a table of odds for education label. This is purely for illustration here. I realize we wouldn't actually calculate odds for this particular variable, but if you had a categorical variable you wanted to calculate odds for, this is how you would do that. So I'm going to call this table education.odds, and then we take the relative frequency table we found earlier and divide it by 1 minus the relative frequency education that we just created. And so this would create the odds for each of those responses. Again, the actual calculation doesn't make sense to do this for education. That's just for illustration. And then we could combine frequency, relative frequency, and the odds together using what is called the cbind function. So in the code above this, we created 3 different tables. The first one was education.freq. We've got education.relativefreq and education ratio, or probably education.odds. Here we have the cbind function, and we put each of those tables in it, run, and notice now we have each of these, and the reason that these were maintained instead of just the numbers is because for education.freq we had actually put these labels in. So notice here we've got the frequency, relative frequency, and odds. So if you want to have those all in a single table together that you could then copy over, you would have that. So that's how we create tables. Now tables are very important because the tables that we just created, we're going to actually use those tables to help us create bar charts and pie charts. So next we're going to look at how to create bar charts, and we'll talk about some different changes that you can make. Alright, so remember we created this object which was the frequency table of education. Here's what it looks like. To make a most basic bar chart that we could possibly make, what we do is we call bar plot, and the only thing we put inside of this function is that table we just created. And here is a very basic bar chart. Now, before we go any further, one of the things that I want to show you is notice right now all of the labels do not appear under the bars. This would be a terrible plot to put into your report. First thing is we want to make sure each of the bars has labels. The easiest way to make that happen is actually just to take the window and make it bigger. And notice now R has enough room to actually put labels under each of these bars. So keep that in mind. All you got to do is stretch this out and you'll get labels under each of your bars. Once you're happy with your plot, and again this plot needs a little bit of work which we're going to do here in a minute, but I want to go ahead and show you how do you actually export this plot so you can use it in your report. Notice up here there is a little export button. If we click here, we can save this as an image. So the first thing you'll want to do, the directory here is going to be automatically set to your current working directory. So another good reason to set those working directories. And then you can name this whatever you want. So I'm going to call this bar plot education. And then you just click save. I'm going to make this window smaller again. And notice if I click on my files, oh, I think I may have actually missaid something. Let me go back to what I just did there. Alright, so let's save this again. Save as image. It does not automatically have your working directory here. That was my bad. You actually have to re-select where you want that to save. So if you want it to save to this class, you will have to re-navigate through your computer to where you would like that to be saved. And again, this is just going to navigate through the folders. Now that I've got in that correct directory, I could call this bar plot education, save. And now if I go back over to my files, it'll appear down here at the bottom. There's that bar plot.education. And you can save that as a JPEG or a PNG. Either of those will export nicely into your Word document. Okay. Now, again, this plot, we'd like it to look a little bit better. So let's change some stuff. First, we definitely need to add a title. So here for the bar plot, I'm just going to call the bar plot function just like we did before. I'm going to give it the table we created, but I'm going to add an additional argument that is called main. Main gives it its title. So I'm going to say main equals, and in quotations, I'm going to have the title that I want. One thing that I recommend adding into titles, which is always a good idea, is the number of observations that were used to create that plot. So for example, we had 6,604 observations for this bar plot. So we run this, and now we've got a nice title up at the top. We can also add in some other labels. So here we just added the title. So notice down here I still have main equals. Let's add in again that n is equal to 6,604. I could have X lab be equal to education level and the Y lab equal to count. And then the arguments here again are those ED levels. You could actually leave that out and this will also run still fine. And so again, now this is looking a lot better, and to get those labels to all show at the bottom, all I have to do is make this window better. So this bar plot, it's looking pretty good. Now, one of the things we've talked about for your EPI reports is we do want them to be visually appealing, so you might want to add a little bit of color. To add in color, all you have to do is do COL and set it equal to the color you want. So for example, if you'd like blue, here is a blue bar plot. So each of the color names do need to be in quotations. There are lots and lots of different colors in R. On Canvas in the Help with R module, you'll find a whole list of different colors and color schemes that you can use with R. Alright, so the bar plots we've created look really nice. There's one issue. Typically, when we're summarizing sample data, counts are fine, but really what we want are those relative percents or proportions on the y-axis. And so in public health data, you're going to almost always see that. So next we're going to look at how could we change the y-axis instead of being counts to be relative frequencies. And in order to do this, we're really going to do the same thing we just did, except instead of calling the frequency table, we're going to call the relative frequency table that we had constructed earlier. So notice here in that bar plot, I've got pretty much the exact same code that I just had up above, except I've got the relative frequency table that I'm calling instead of the frequency table. So let's run this. And now that is a nice looking bar plot that you could include in your EPI report. The only last piece that I would consider changing with this bar plot is notice here at this very last column we've got refused. For a lot of the variables, you're going to see either a refused or an unknown category. Those aren't very informative. So a lot of times what we'll actually want to do is remove that column and just look at the actual responses that we got that were meaningful. And then of course, anytime we remove something or there was missingness, we always document it. So in this case, if I were making this bar plot for education, what I would want to do is make the bar plot without the refused, and then kind of as a footer on my plot, I would say something like there were no missing values and this many people refuse to participate or refuse to respond. So that way I've still documented the refusals, but they're not getting in the way of interpreting my plot. So let's look at how we can do that. So we're going to look at how we could remove levels of a variable before constructing. And so in this case, we're going to remove the refusals for the education. Different categorical variables might need to remove different levels depending on what the values are. So to do this, what we're going to do is we're going to define a new variable, make this a little bit bigger here, called education.responses, which removes things like don't know or refuse to answer. So we're going to start out by setting education.responses equal to our original variable. So again, if you were working with a different categorical variable, let's say race, you might have race.responses, and then you would call the race variable from your data set. First thing we're going to do is find the refuse to respond. So if we go back to our code book for this variable, notice that a refused is coded by the number 9. So what I'm going to do is I'm going to find what values need to be removed. So I'm going to create an object called values.remove, and I'm going to set it equal to which of these values was equal to 9. So for yours, you would call your variable you're interested in, and then whatever values you want to remove. And I've got a little note down here if there's more than one value that you'd like to remove. So once you've defined the values to remove, what you do is you set education responses equal to itself, but minus the values we need to remove. So if we run this, and just as a sanity check here, let's call that education frequency table that we had earlier. Remember that there were 15 refusals. So what we're going to do is we're going to make sure that we only remove 15 values. So running this, right? So let's now look at education responses, and it's going to appear over here. So notice education responses now has 6,589 observations. Well, that's equal to 6,604 minus 15, so it did what we wanted to. Next, what we're going to do is create a relative frequency table of this education with refused removed. Because notice now we're not going to divide by the total number, we're going to divide by the total number minus the 15 because we're redoing our relative frequencies here because we've completely removed the refusals from the data set. So the first thing I need to do is now figure out how many responses I have. So I'm going to use a new function to do this. It's called length. And length is going to tell me the length of this new vector I just created. And then again, I'm going to subtract off any missing values just like we did before. So notice if I run this, my number of responses is at 6,589. So why did I put a 2 after this? The reason for that is earlier I already used the name in responses, and I don't want to overwrite what I did previously, so I just put the number 2 after it because it's a new object that I'm going to use to store the number of responses for this variable. I could have just as easily done n underscore responses dot ed underscore no refuse, or some longer name, but the name is already getting pretty long, so that's why I just put the 2 after it. Next, I'm going to create my new relative frequency table. So here, just like I did before, so this code is pretty much exactly the same. The only difference is now I'm going to use the table function on education responses and divide by my new number of responses. If I want to add the names in, just like I did before, but now my new education levels, and I'm just calling them ed levels 2, are the same as before, except I've taken refuse off the end. I've added the names. And then we'll add in a line of code here so we could actually look at that new relative frequency table. And here's our new one. So again, all these relative frequencies are now calculated, removing the refused. And so the very last thing I'm going to do is create my new bar plot. And so notice here I'm calling that new relative frequency table I created. Make this bigger. And now we have a perfect bar chart for your EPI report. I've removed some values that weren't necessarily informative. I am going to note though that I did that. All of my bars are labeled. I've got proportion on my y-axis. I've got a good title. Oh, there is one thing that I want to do here though. Let's add into that new title our number of observations. And notice my number of observations have changed. Since I removed those 15 values, this bar plot was not created using a sample of 6,604. It was created using a sample of 6,589. So rerun that. And again, now we have a really nice bar plot that would look great in your EPI report. And then again, to export that, we could click on Export, Save Image, and then you would have that image file that you could then put in your report. Alright, so the very last thing we're going to do is we're going to create a pie chart. Pie charts are going to be very similar to bar charts. They're going to use those frequency tables that we made earlier. So just as a reminder, let's look at that original frequency table we created. We could call pi, the function pi, giving it that table as an argument, and here is the pie chart it creates. It looks okay, but it needs a little bit of work, so let's see some stuff we could do. First thing we could do is add a title, just like we did before using the main argument. That looks a little bit better. I could add some labels. So here for the labels, what I'm going to do is I've got those education levels just like I did before. So this line of code is really redundant, but I just put it here to remind us. And then notice inside of the pi argument, I'm going to set labels equal to those education levels we created. So there those are again. The reason they repopulated this time, they were there before, but the reason I put this in here is in case you don't have the labels and it's coded as the number values from the code book. This will replace that. We could also add some percentages to our labels. So this line, or all of this code will do that. So there's the end result. So notice that's nice to have those percentages, and you really want that. And for that code to do that, kind of looking through here, the only pieces that you're going to change, again, are going to be anything that you've created dealing with your variable. So for example, if you were using race, you would use the race relative frequency here. Instead of ED levels, you would have race levels. Instead of ED level percentages, you would have race level percentages. And so notice here, you would have race dot levels, the PCT you already created for percentages, and so on. So the only thing you want to change in here are the pieces that deal with education, and you'll want to make sure they match what you did for the variable that you're interested in. We also learned in pie charts we might want to sort them by frequency, so this code will do that for you. And then finally, you might want to add in some color change. Make that a little bolder. That's what that would look like. And I'm going through this code pretty fast. It's very similar to what we did up above. So if you need help going through this to figure out how to make the changes, just let me know. And the last thing we have here, this is combining the last two pieces, which is sorted by frequency with the color change. And so notice by combining those two pieces together, this looks a lot nicer. Now, one of the other things I did that made this look nicer in this code is I also removed the refusal. And where you can see that in the code is, notice instead of calling the education freak, I've got education freak sorted to, where I sort education relative frequency to. One of the reasons that's a good idea to do is if we go back to the previous plot, notice that refused and kindergarten or less overlapped each other. You do not want to have that in your pie chart. So if you're getting a pie chart where you have the labels are overlapping and you can't figure out how to fix it, let me know and we can look at that together. You either probably want to remove the refusal or like the unknown ones. You're pretty much always going to go ahead and remove those, just like we did with the bar plot. And that will usually fix the problem, but if you still have the problem like that afterwards, let me know. The other thing that I do want to say with this, I went through the pie charts pretty quickly here because I wanted you to see them, but you don't want a whole lot of pie charts in your EPI report. Pie charts are good if you have a variable that just takes 2 to 3 levels. Really, once you get more than that, a bar chart is typically better. So if you're, for example, summarizing gender or sex, pie chart might be okay, 2, 3 levels. But if you're doing anything that has more than that, I really wouldn't recommend the pie chart. I would really look at a bar chart instead. They're typically a better summary, and people usually like those more. But I did want you to be aware of the pie charts. So again, I went through the pie chart pretty quick. So if you have any questions on how to edit that code or to change it, what you need for your report, please let me know.